This is another type of example that gets solved using your alpha plus beta formulas. I have a name for these kind of questions. I call them double triangle questions. And the reason I call them double triangle questions is because we are going to have to draw two triangles in order to solve this. We're going to have to draw a triangle for alpha, and we're going to have to draw a triangle for beta. And in these double triangle questions, there will always be enough information to figure out what quadrant alpha needs to be in, and there will be enough information to figure out what quadrant beta needs to be in. This is on page 637. This is the easiest one because look how easy it is to figure out what quadrant alpha is in. Alpha's in quadrant 3. Nice. So we can draw our triangle for alpha in quadrant 3. Again, we always draw our triangle back to the nearest x-axis. So this becomes our reference angle for alpha. And because we know that cos of alpha is -3/5, in this triangle we would know that the adjacent side over the hypotenuse would be 3/5. Do you recognize this triangle? What's the other side length? 4. And that's going to be helpful because we already knew that cos of alpha was -3/5, but now we know sine of alpha is -4/5. And our second triangle will be for beta. And again, this is as easy as it gets. What quadrant is beta in? It tells us it's in quadrant 2. So when these become more difficult, you would get this question. They would say sine beta is equal to 1/3 and cotangent beta is less than 0. So then you'd have to think, okay, cotangent is negative. That means tangent is negative. So according to my cast rule, where would sine be positive and tan be negative? That would be in quadrant 2. And then you'd be able to draw it. So this one's easier because it tells us directly that it's in quadrant 2. But sometimes you'll get double triangle questions where you have to use your cast rule to figure out what quadrant the angle is in. So there I draw my triangle. I can label my reference angle for beta. And since sine is 1/3, I know this side is 1, this side is 3. A squared plus b squared equals c squared. Hopefully you're getting really good at doing those in your head by now. That's going to be the square root of 8. So now we knew that sine of beta was 1/3. We now know cos of beta is -√8/3. Now, we are asked to find sine alpha plus beta. And our formula sheet says that sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. So after you've substituted the values in for everything that you have, now we just need to write this as a single fraction. 3 times 5 is 15, so on the top here we're going to have 4√8/15 plus -3/15. None of those are like radicals, so we can't put them together. So our final answer would be 4√8 - 3 all over 15. So for these double triangle questions, they're non-calculator. You draw both of your triangles to figure out what cos alpha and sine alpha are, and then you plug them into the formula. Yes? Yes, you could simplify the root. So if you wanted to, that √8 is 2√2. So we could write this like this, and most likely in your answer key, this is how it would be written. Okay? On your final exam, they assume, just like they assume you know how to simplify fractions, they assume you know how to simplify radicals. So if you leave your radical unsimplified, it would still be considered correct. And so you don't need to simplify square roots on an exam. Where you do need to simplify them is if this was a multiple choice question and the answer looked like this, you would need to know how to get from here to here. Another important thing when you're doing your work is if you get your answer like this and the answer key looks like this, you should be able to know how to change it so that it matches the answer key. In fact, when you go to university math, often you're going to look at the answer key and you're sort of going to try to solve the question like a proof. You know what the answer is supposed to be, and you're trying to solve the question to make it match. Okay, we're going to take some time to practice these double triangle questions. 8 and 13.